Besides having increasing and decreasing intervals, you can also have a constant interval. So down below, we're looking here at a constant function. The equation for that is f of x is equal to c for every real number x. So no matter what you plug in for x, you're going to get the same value out. Our example down here is f of x is equal to 3, or the line y is equal to 3. Constant functions will always be horizontal lines. Okay, so we're going to include that in our increasing and our decreasing, and we'll use a color for that as well. So let's go over to that part. I'm going to do my increasing in red, decreasing in blue, and constant in green. One interval increasing, another one that's going up. Again, make sure to trace from left to right. Constant would be that flat line right going across the middle, and then decreasing is going down. And then to write that information, once you have that sketched out, we're going on the x values. So you might even want to just kind of trace where these different breaks are occurring. So we're going from negative infinity to -1 first for the increasing, union, and then the next time it's increasing is starting at 2, and that only goes to 4. Our decreasing interval is starting at 4 and going to infinity. There's only one of them. And then our constant interval, the green interval, is going from -1 to 2. So when you look at all your intervals, you want to see that the numbers there are matching up. You're going to be using the same numbers where one starts, the other one stops, and vice versa. That's important. Now another important thing here, and I'm just going to get rid of these vertical lines so we can see a little bit better. Get rid of all my increasing, decreasing stuff. I'm even going to get rid of the increasing and decreasing as well. We have a positive part and a negative part and where it's equal to 0. So we have two parts here where the graph is equal to 0, and that's at -3 and 5. At that point, or at that line right here going across, that's what's separating what's greater than and what's less than. So I already kind of used some of these other colors here. I'm going to use this orange. Actually, let's see if I can switch it over. Okay, so we're going to use purple for everything that's under the x-axis. So if it's under, it's a negative or less than 0. So it's less than 0 from negative infinity to 3. Negative 3. Let's fix that up a little bit. And then again from 5 to infinity. So you should be using the values that you wrote down for when f of x equals 0 to do the less than. And then we're going to go above the axis. I'm going to use another, it's kind of like a darker purple. Everything up here above those 2 points. So we're only going from 3 to 5 on that one. Okay, so we have increasing, we have decreasing, we have the constant intervals. And then you're also going to look at the above and the below the x-axis. So if you're marking up your graph with colors, You just have to be careful what you do with what. You might just want to put, when you get to this part, to just really darken in that line going across the middle to see what's above and below. And once you've identified these x-intercepts, or where it's equal to 0, it's going to make it easier to do when it's greater than and when it's less than. Okay, our last intro situation is average rate of change. So it says average rate of change on A comma B. So this really is talking about the interval AB. Essentially, average rate of change is just slope, y2 minus y1 over x2 minus x1. Another way to look at this or to write it using A and B is f of B minus f of A. So we're doing the second minus the first over, and then you're going to do B minus A. So you can almost look at the interval as if it's a point, so it's kind of like slope. And it really is the slope between those 2 points on the graph. It's the rate of change between those 2 values, so it really is like slope. It may just not be going through the graph like it is on a line. Alright, so to find the average rate of change between -3 and 4, we're really looking at those 2 values. So you can go to the graph and look at the points. So that we have the point, if we do f of -3, that value is 0. We already know that because that's one of our points that worked. And then if we do f of 4, we're going to get 4. Okay, so we're going to do the rate of change here. We'll do 0 minus 4, which is f of -3 minus f of 4, divided by -3 minus 4. So again, really, the y value minus the x value. Y values minus each other over the x values. You'll get -4 over -7, which is going to equal +4 over 7. So if you can do slope, you can do average rate of change. It's the same thing. I just noticed a mistake that I made up here. This should be a -3, and I have a +3. Hopefully you noticed that already, but if not, just make sure you go back up and fix it on the notes. Everything else said -3, and I did say to look to make sure things matched up. Okay, we're going to use this information now to explore some of the graphs that we will be looking at all year and coming up with these increasing, decreasing, and constant intervals and average rate of change with those different types of functions. This was just your introduction to the different ideas that come up in graphs.